Alright, should be recording, hopefully. Not making errors again. Anyway, I just lost the last video, which is quite irritating. Pretty good video, I think. But anyway, I'll try to duplicate some elements. So first I inquired, because there's been a few of my videos, like 3 of them are getting a lot of views, like over 1,000. So I figure somebody's embedding them somewhere, and I'd just be curious where. I know the Zohar guy was doing the Discord thing. I don't know whether he did it or somebody. Just curious, like to know where they are, if they are somewhere. Didn't really get anything out of it in terms of subscriptions or anything like that. It's just the view numbers are up. No comments that were rational. Usual amount of spam, I'd say. Well, whatever you want to call it. Just crap. So it's a really simple agenda here, right? I mean, I'm perfectly willing to defend what I'm saying. And so all you have to do is make some sort of accusation that isn't personal, you know. So if you can actually demonstrate that I'm wrong, give me a link to a video demonstrating some physical fact that isn't consistent with my theory, fine. A measure of evidence. Fundamentally, the argument's kind of simple. You know, people use words like falsifiability. The current theory is pretty falsifiable in the sense that there's real indications that they're wrong. Stuff like the double slit in photons not creating the gradual pattern it's supposed to. You know, the mathematical errors in all of the galactic lensing images are insane. I mean, they're so egregious, the flaws, the inconsistency with predictions, the Eddington experiment never being redone, not redone when there was a perfect eclipse, and never done from space, where it's really easy to do. A small telescope can do the job. Never done. You know, it's like kind of glaring that they've never proven a photon is ever bent by any force ever. So it's all this really weak evidence for a whole, you know, model they've created that has all kinds of wooey in it. You know, photons have radar, photons can do calculus, photons pop into new universes and make new universes. You know, just extraordinary claims, very less than ordinary evidence, not even any really evidence. It's completely discardable in terms of its such thin indications that, you know, you can't take it seriously at all. They have not met any kind of burden of proof. They haven't met any burden of arrogance. They really have no right to be obnoxious slobs in terms of walking around like they're superior and they have a great theory and it's proven, when they haven't done any of that. They haven't done any of the work of proving it. They've just, you know, done the part of saying it. You know, keep saying it. Keep saying that we did everything. We invented everything with our theory. You wouldn't have popsicle sticks without our quantum mechanics. I mean, just, you know, silly exaggerations. We're all stuck with the fact that we can't see photons, can't see the little tiny universe. It's elusive, and so we're all stuck with a certain amount of evidence. And the rule is whoever's the most consistent with that evidence and provides you with the simplest explanation wins. And that's the way it should work. And they don't want to play by those rules, obviously. And so, but I'm going to oblige them to. You just have to do better than insults to my personal character, integrity, or something else, you know. Especially when they're completely unfounded insults, irrelevant insults. So anyway, so to the trolls. So one idiot, jerk, commenter, made some point about the, you know, I've given you a perfectly reasonable explanation why some matter overcomes drag, and the simple argument is that a group of electrons and protons, that is, you know, 4 protons and 2 electrons, can create a configuration, that's a helium nuclei, where the energy can go in and it stays in a sense, and it just bounces back and forth, but the initial momentum is preserved. So I have showed you an animation twice, I think, of something jerking across the screen, in little bursts, and then it stops and then it bursts. So the idea is the energy goes in and the forward momentum is conserved. And so that's always a first. And then the rebound never undoes that first impulse. It just goes from going forward to going nowhere, to going forward to going nowhere. So it stops and goes, stops and goes. It doesn't go the opposite direction. That's not what stopping is. So anyway, the idea would be as this first surface gets hit, it moves, the whole container moves to a new position, which means the trip backwards is much shorter than the trip forward. So it stops when the arrow is going forward. It's not moving, so it moves the full distance of the box. And the box is moving when the arrow is going back, which means it is a shorter path. And so some relativist out there was making some argument that this is happening. I drew a circle and demonstrated in the animation with the circle. And clearly there's no equal amount of travel time for the force. The force is always moving the speed of light, but he says from the perspective of the circle. No, there's no perspective of the circle. The front end of the circle is seeing something completely different than the back end. From the front end's perspective, okay, the force leaves, is going away from it, and from the other side, the force is coming at it, So from those two perspectives, it's like if I was going to put a pie in your face and I move the pie away from you, versus moving the pie towards you. I mean, obviously, if somebody was going to throw a pie at you, you're on a train and you're going 50 miles an hour on a train, and somebody throws a pie 50 miles an hour from the ground at you, the pie is going to hit you at 100 miles an hour. That's the fact. It's going to be a 100-mile-an-hour impact, combining those two velocities. And the same is true for the fact that, yes, light always has a constant speed. It's always going 50 miles an hour. But the fact is you can be moving 50 miles an hour into it, okay, and your perception, that is, you're going to be removing distance from the trip, and so obviously you're going to see it as moving faster than 50 miles an hour if you're going to assume you're not moving. So, but what's the perspective of the circle? I mean, it's just so silly. The perspective of the circle, from one side of the circle, the pie is heading 50 miles an hour right for him, and from the other side, it's moving 50 miles an hour away from him. So anyway, 100 miles an hour away, because he's going away as the pie is going that way, and obviously it's going to look like twice as fast. Alright, sorry, I shouldn't have to explain all that, but there's a simple explanation, and they just keep desperately trying to make this convoluted nonsense of some warped and bent time, space, dimensional crap make sense when it just doesn't. There's one universe, everything's in it, and everything's obeying the same rules. That's it. It's not any more complicated than that, and you have absolutely no evidence that it is more complicated than that. None. You have none, and you especially don't have anything called proof of anything. So anyway, so that comment I had deleted because I had responded to it, so sorry that I didn't get to read it again, but the circle's perspective is kind of a silly thing to talk about when the circle has two surfaces. But anyway. Alright, so another comment I did get was from Perv Action, who cited a video that has just another view of what I've shown before is the interference pattern, the pattern you get, the on-off pattern, when using optical flats and, certain kinds of light make it more visible, but you get a clear striped pattern, and they use that pattern based on this idea of the reflective angles of the internal reflections. And but yes, the link is there, but it doesn't show it any better, and it certainly doesn't provide any explanation for how the pattern is created. And so I did find a Van Briesen video that does go through it, so I thought maybe I'll go back to that and play it again. I just played it for the first time, and it's a little more fun when it's fresh, because now I know how he's cheating the argument So I don't get to discover how he's cheating it in the video as I did in the previous video. That didn't get recorded. So anyway, and then the fly guy is off subject. I mean, look, I provided an email address. You know, if you really have to do the off subject stuff, just send me an email. But do you really think I care about coronavirus? You think I have some like special hotline to China and I got all the info on whether this one's real? You know, I mean, how many false alarm panics do you have to go through in your life before you realize, you know, they're all full of shit, so to speak? You know, this is like every snowstorm is the mega storm. You know, it's all hype. It's all because the media has to sell ads, you know. So they have to make everything into more than it is because they have to sell stuff. I'm not saying this isn't bad. I'm not saying blah, blah, blah. But just look at the evolutionary history. You know, it's very rare that a virus comes along that wipes anything out. It can do some damage. You know, it can reduce a population's numbers, can do lots of stuff to make it less competitive, all of that stuff, but it's just not in the nature of the survival beast that we are to be wiped out by something as silly as a virus. But anyway, yeah, moving on. Yeah, so I guess I'll do the Van Briesen thing. I don't think there's anything else to say. So yeah, I've actively solicited a rational conversation where I can challenge your physics by forcing you to answer questions like, well, why doesn't the slit experiments produce the light pattern it's supposed to? Why doesn't the pattern in photons look like the pattern in electrons, you know, which looks very wavy? The math says so. Why isn't the reality so? You know, and I can point out that, you know, in the radar experiment, the geometry for jamming is exactly the same as the geometry for an interference, and so why couldn't it be jamming? Simple answer, uncomplicated. Yeah, you know, the lensing stuff, and then you could challenge me, right? But you really can't challenge me because you would have done it by now. You would have linked me to the great video that explains something better than I've explained it. Go ahead, link me to the great video you think is indestructible, that relies on quantum mechanics or bent space. You know, the video that has something called evidence in it somewhere. Alright, anyway. Just cowards. I mean, I've offered money to physicists to critique my physics. You know, essentially a blank check. Tell me, what would it cost for 2 hours of your time? And they don't even reply. Yeah, gutless. Anyway, alright, so I'll be back. Hopefully without failure. Let's see. Alright, should be back. Just to make sure. Appears to be working okay. No funny colors, blah blah blah. So, Michael Van Briesen, again, a nice enough guy, but this video is just, it's a series of 8 videos. I haven't watched them all yet, but it gets to this small, thin film interference patterns, which is the subject of the previous comment, and is, again, maybe there's something in here, some way to prove one way or the other. I think the polarization filters sort of proves the point that photons aren't being destroyed, that they're being reclamated. And what they're calling constructive interference is really reconstructive. You're just putting broken photons, you're taking 2 fragments and putting them back together. Simple explanation.
Physics, it's called the interference of light, and in particular we're going to look at the path and the phase difference of light. So when 2 beams of light come together.
So let's point out, phase is in the title, and he just said phase difference, but he's not going to use, you know, he's not going to point out something that needs to be pointed out.
And let's say that the sources are the same type of sources, so they put out light of the exact same wavelength and exact same intensity. But if one is placed slightly...
So he didn't say the same phase, which is the key point. So you can't do this with 2 separate sources. There's no experiment this is based on. This drawing is just absolute nonsense in the sense that, no, you can't do it that way. You have to take a single beam and split it to get 2 in phase. You can't create 2 mechanical sources in phase because we can't create photons. We have to rely on matter to create the photons. We have to rely on the chemistry to do it. We put electricity in and we allow the chemistry to do it. We don't create the frequency. Like in radio waves, we create the frequency. We pump it in. When you're making light, you don't pump the frequency in. So we don't get to control the phase of the sources. So this won't work with 2 laser beams. He's implying that it would, clearly implying it, you know.
Different from the other, you can see that the light has to travel a different distance from the one source as compared to the other source. And this.
So again, the sources would be the same source, and you're splitting them and then causing one to travel a longer path, which means you will knock it out of phase. So I've used different analogies, but it's like having marching soldiers, you know, and you send them from a point, and you can sort of understand that, you know, if you send them from over here and from here, that the 2 paths, and you want them to intersect at some point, well, 1,000 steps from those 2 locations will be at a different, they'll be out of phase. One will arrive sooner than the other one, and so they won't be marching in their row. So you won't have a wave of soldiers. You'll have an out of alignment. And it's not until you make the distance a little bit longer that you get them back in alignment. Okay, you lose the first row. The first row doesn't have a complement. But the second row, you will have a complement, you know, and the third row and the fourth row, once you have the distance on phase. So it's really just the fact that the waves have a phase. If you knock it out of phase, okay, it can't be detected. It won't be seen as a wave of soldiers anymore. It'll be, yeah, like I said, we can only detect it if it's in this, all the soldiers are in a row. If the soldiers aren't in a row, we can't detect their existence. That's the simple premise underlying all of this.
You can see that the distance x2 is a little bit larger than the distance x1. So when the 2 waves of light come together, they will interfere with each other. Now
right. There's no evidence that the photon ever interferes with another photon in any way. They don't do anything to each other. They can't do anything. The argument, the simple explanation is that you break photons and then you remake photons. So I guess I might as well do that now, just to alleviate any confusions. I should clean it properly earlier because it doesn't clean later. Okay, well maybe I'll pause. Properly clean the board. Yeah, it should be back. Not that much cleaner, but whatever. It'll do. Alright. So the simple argument is that you're sending photons through a thing. Okay, and the photons have an arrangement in space. And you send them through some device. Okay, whether it's a slit or a filter or whatever. You make them hit something, even a surface, and that's going to change their order or arrangement in the sense that they have a specific frequency. And what's going to happen is, as I've argued, their polarization essentially means that they're a little bit in different alignments. And so they have a frequency. Oh, you can't see that. Alright, now you should be able to see that well enough. Alright, so they have an alignment. And what happens is when they go through this filter, slits or something, the alignment gets broken. So one over here is aligned up, and I got more than one thing there. And say this one gets wiped out here. So the frequency gets broken in the sense that it's missing an element here or it's missing an element here. And so there's not enough information. Okay, you need it to go, you need to hit something, like say if it was a spring, and you need to compress the spring down to this far, all right? And so you're going to hit it, and you need all of these things to be there. So you need to hit it and hit it and hit it before it can rebound. But if one of them is missing, okay, there's no thing there, then the spring can rebound, and you'll never get to this, you'll never get it compressed all the way down. And that's the basic mechanics of the function of how we detect photons. So the idea is that you really are going to take a photon that's broken, a fragment, okay, so it's got this bit, it's missing that bit, and it's got this bit, this bit, this bit, so it's missing this one. And then another photon coming from somewhere else, and it's got this bit, and it's got that bit, but it's missing this bit, and then it's got this bit and this bit. And those two meet, all right, you're going to realign them, okay, back into the real game, and now you can still connect the dots in the sense that where this one's missing, you have one here, and then you can just bounce this one over here is going to take this place. So now you have a frequency again. So yeah, you have 2, 2, 1, 2, 1, 2, but the point is you regained a photon. You got one photon back, okay, out of these two broken pieces, and that's the important part. So it's just realigning them, taking ones that have different pieces of their rayness is broken, a little different piece of it, and once you put them back in phase, you can reconstruct them. Now, if you left them out of phase, that if these things were in the wrong places, well, you can't reconstruct them anyway. Okay, you can't put them, if they're out of phase, you can't reconstruct them back into the right pattern. So you have no hope. But when you got them back in phase, you have hope of rebuilding the photon. Right. So when he has those two beams, what he's not telling you, which is the plain truth, those two beams have already been affected. And so the gun 1 and the gun 2 are already affected. That is, half the photons are in the broken phase. They have a piece missing. They have elements missing, and they can't be received as a photon. So it's already half intensity. The two beams are already half intensity beams because they've already had half of their photons. So it's like going through the first filter in an arrangement of polarizing filters. The first filter wipes out half the photons. Okay, it breaks them. They're not gone, they're not destroyed, they're just disabled. And if you put two disabled ones together, right, some soldier with a broken left leg and the other soldier has a broken right leg, and the two of them together, though, can walk, theoretically. Right? So all you're going to hope for is that from these two sources, you'll get a broken fragment from this one that has a different, is broken differently. Well, whatever, I'm not going to try to draw broken, but yes, broken, 1 and broken 2, and they're broken in a way that's compatible. So when I put them back in phase, I can rebuild a photon. Where if they're out of phase, I can't, because their phase is wrong. So even if they have the right pieces, they're in the wrong frequency. All right. Simple explanation for all of this nonsense. And like I said, his end conclusion is so wrong in the sense he's basically going to argue that if I put two beams together, if I shoot two lasers at each other to a spot, the spot has 4 times as much light in it. That's the clear statement he's going to be making, essentially, based on this theory. And the only way that could make any sense to you is you already understand that, no, that's a half beam, and that's a half beam, because it's already been through a filter. So it's like saying, yes, if I put them through a polarizing filter and another polarizing filter, then I can get a whole photon, a whole beam back. So I can get 4 times the half energy, okay, by getting 2 full beams worth of energy back. But that'd have to reconstruct all of the photons.
We can either have constructive interference or we can have destructive interference. Constructive interference is obtained when the path length difference.
All right, so let's understand there's no constructive and destructive. All there is you make photons, you break them subtly, small little break, one little element's missing. And if you put them next to, you can take 2 broken bits and make a whole again. So it's reconstruction. So you can have constructive reconstruction, or you can have non-constructive non-reconstruction, in the sense that you can't put them back together if they're out of phase. So your only hope is, first you have to have them in phase, and then you have to have 2 broken pieces that are capable of fixing each other's liabilities, compensating for each other's deficits. One has A, B, C, the other one has A, B, E, and the other one has, B, C, D, and then you have a whole photon again.
Is equal to an even number of, or not even, but an integer number of wavelengths. For example, if the extra distance traveled, and I define the extra distance as being the difference between x2 and x1. So if the extra distance traveled by the second wave compared to the first wave, if the extra distance traveled is equal to one wavelength, or two wavelengths, or three wavelengths, or so forth, an integer number of wavelengths more than the other, then they are in phase when they arrive at the same point, and then you'll see constructive interference. But, however, if the extra distance traveled is such.
Right, so to say extra distance is just, again, to point out that if there were waves of soldiers, you know, lined up, marching, all you're talking about is the fact that if you're sending from, they have to travel more distance, so this one has to travel more distance, that it won't show up in alignment with this wave. It just can't, because it has to travel more distance. So the more distance just means how much out of phase are you, how much are you falling behind, because you're going longer distance, you're falling behind. And the longer the distance I make you fall behind, right, I can make you fall, and then finally I can fall enough distance where I'm back on phase. And if I keep going at that distance, I will reconstruct the phase. I'll be back in alignment with the other object. So the distance just has to do with the fact that as you increase the distance, you move them out of alignment. It's that simple. I mean, it's just how much are they out of alignment. And distance means you're not going to be able to get to the same point at the same time. If one thing's closer to it, and you just want to be far enough behind where you're back on phase, in the sense that your waves will realign.
That it's a half a wavelength, or 1.5 wavelength, 2.5 wavelengths, or so forth of extra distance. So if the extra distance is equal to a half a wavelength, or 3/2 of a wavelength, which is 1.5, of course, and 5/2 of a wavelength, or so forth, then we have what we call destructive interference.
So the point is destructive just means any out of alignment means the photon can't be seen. So there's sort of a strict requirement that the photons have a specific amount of distance between them, and if they vary, that's not going to be receivable by our equipment as a photon. It's not going to be able to compress the spring the right way, because the energy isn't perfectly to the resonance, the rebound speed of the spring. And and anything that's off is going to be considered off. There's no like a little bit off and a little more off and a little more off. We can't detect any of that. Off is off. So they just call it a 180-degree phase shift, when it could be a 60 degrees phase shift, could be a 30-degree phase shift, could be 150. I mean, could be any one of those. And they just call it one thing because it's always going to be broken. They can't, you know, broken is all they know is on and off. That's the end result. So they just pretend it's a 180-degree phase shift, when no, it's some real number of off. It's not 180 degrees off, it's the specific amount off depending on the distance. But the fact is that any out of alignment is off. Too much out of alignment is just, it's either on or off. There's no, you know, half broken. You either fix it or you don't. You always have to have 4 tires on the car, kind of thing. 3 tires just won't do.
And if the extra distance is exactly half wavelength, or 1.5 wavelength, 2.5 wavelength difference, and when the two beams come together, they will actually cancel each other out, and you'll see nothing on the screen. Just be a dark spot there, and no light will be seen. They literally cancel each other out. The reason for that is light.
He said it. You know, like I said, they're asserting a truth for which they have no evidence. They have no video of photons waving. Their own theory doesn't make much sense. So let's understand again their understanding of the magnitude of this thing. How much space does it occupy? A photon occupies thousands of atoms worth of space that it fills. This field perturbation, whatever you want to call it. And their argument is this thing covering thousands of atoms worth of space slides into a piece of matter, but it only affects one tiny electron. So it's not like it affects just one atom. It just affects one electron. Something thousands of atoms large somehow just picks one of those electrons and says, I'm going to bother you. I mean, their theory doesn't, it has no continuity. It doesn't make any sense.
is an electromagnetic wave that has electric field oscillations and magnetic field oscillations. And so what happens is when two light beams come together that are coherent, that have the same wavelength, the same frequency, and have the same intensity of the sources, when they come together, we could have a situation where the electric...
I mean, again, this is just a religion. They just made all of this is just a story they tell, because there's no way for anybody to prove it wrong, because they can't create any more evidence. I mean, the evidence, we can't see photons. But again, the evidence is deductive. You can point out that their theory doesn't fit, because their math doesn't in fact work. It won't, the math says the pattern should look a certain way, the pattern doesn't look that way. It's just a fact. Fact is that if I put two sources and shoot them at the same spot, I won't get 4 times as much light. It's a very bad theory.
Field oscillations in one direction and the other field oscillations in the opposite direction, such a way that they cancel each other out. So the best way to look at that is to say, if they're in phase when they arrive, that means that the electric field oscillation of the first wave is in the very same direction as the electric field oscillation of the second wave. And since these are vector quantities, they must be added vectorially. You can then see that the total together...
Right, and this is where they get into trouble, because they're turning this again, you're playing the sine wave game, and this is why, like in the radar experiment, when you put an audio tone on the signal, you'll end up with a 4 times increase, but it's because of an artifact of amplification. It's the artifact of when you double the diameter of a circle, you quadruple the area. Well, the same thing happens with your sine wave, and so you make it much more intense by doubling its amplitude. You create a huge amount of volume or area that the wave now occupies. But there is no evidence that this is true. You can't make this true. And like I said, the only experiment that sort of indicates it, the explanation is you're still stuck with the fact that no, that's a byproduct of the fact that you put a tone on top of a carrier signal and you amplified the tone. You took something that was a discrete bit and turned it into a sine wave when it wasn't one, and then you multiplied the sine wave and quadrupled the area, but there's no evidence it was anything other than just an on and an off, just a bit of energy.
Is equal simply to the sum of the one plus the sum of the other, and of course that means that the electric field oscillation for both of them together is double the oscillation for either one separately. But if they're out of phase, like a wavelength out of phase, 180 degrees out of phase, if they're out of phase...
So again, he puts them 180 degrees out of phase, where no, the amount of out of phase they're going to be is completely dependent on this distance. So obviously if I just make this distance a little bit of distance, right, if it's a tiny bit difference off, well, then they're only going to be, say, 30 degrees out of phase. And then they're, like here, is 60 degrees and 90 degrees. There's a real fact. And they're just turning it into, well, it's either on or off. So we're just going to call everything that's more than, say, 22 degrees, everything, because that's when it breaks. We'll just say everything above 22 degrees and below 180 degrees is off. And that's it. When that's not the truth. The math isn't describing the truth. I mean, realistically, you kind of have to understand that, right? I mean, you can't have a phase change if you don't change the distance. And there's lots of ways when they do thin film especially, where they create a phase change when there's no explanation of the extra distance. They just say it. It's a rule. And there's no rule.
What that means is that the electric field oscillation of the first wave, E1, will be in exactly opposite direction to the electric field oscillation of the other one, E2.
Right, and they could just as well be just a little bit off, where they're only losing 20%, where the one big wave is still the right direction and the other one's the right direction, so they're most of the time they're contributing to each other, and they only lost a little bit. But any loss means you can't compress the spring. That means you don't have a photon. So you can't get away with any more than, like, whatever, 10% being off 10%, and that's it.
There's E1 and E2. So when they come together and you add them together, they exactly will cancel each other out, because two vectors that are the same length but opposite direction will simply cancel each other out. So you can see that E total.
So again, this is turning it into a vector when it's not a vector. It's a real piece of energy, and you can't make it go away. So all you can do to a system is, create balance or add energy. So again, like the ball moving, the little circle, you can either go forward, you can add energy going forward, or you can stop it. But you don't have the ability to do the other thing, reverse it. And the same is true inside of something. You'll either hit some energy that's going the opposite direction, and the two of you will create a zero, or you'll push more energy into a system where you'll add it because you're going the same way the rest of the fish are. That kind of thing. But there's no destruction anywhere. There's balance or imbalance. You're either adding imbalance or you're creating balance. You either quiet the system or you give it more energy. You agitate it more. Those are the only two choices.
In that case, is simply equal to E1 plus E2. And of course, since E2 is in opposite direction from E1, that is therefore equal to 0. And since the intensity of light is proportional to the oscillation intensity squared, you can then of course see that the oscillation intensity is 0, therefore the light intensity will be 0 as well. All right. So,
but the truth is, though, is that that's not what each one is doing. They're not perfectly out of phase. They're not 180 degrees out of phase. All they have to be is any degree out of phase, and we can't see it as a photon. If it's 500 nanometer light, right, and I make one part of it 480, and I make another part of it 320, it can't have irregularities in it. And so that's what this is basically saying. You can't have one frequency have multiple frequencies in it. The tolerances don't allow that.
So, how do we find the intensity of the beam right here, of the two beams as they come together? Remember, the intensity of light is actually equal to the what we call the magnitude of the Poynting vector, and one way to describe that would be 1 over mu sub naught c times the electric field oscillation squared.
All right, just see if it's still recording. Yep. So again, they're using the mu sub naught, which is mu 0 and epsilon 0. So the two sub pieces that equal the speed of light. So they have two constants, the electric constant, the magnetic constant. Those two constants equal the speed of light when you do the 1 over their square root. And so this is just basically saying that you're going to bisect 10 into two numbers, 6 and 4. And then you're going to multiply 6 times 10 and divide that into 1. And then you're going to do 4 times 10 and have that 1 divided into. And then you're going to do this as a reciprocal, and therefore the two of them will be the same thing. It's an unnecessarily bisected constant. So they just took the speed of light and bisected it into two different but and disproportional numbers, and so one number, its inverse, ends up being the other number.
Now, of course, when we talk about electric field oscillations here, we talk about the average value or the RMS value of the electric field oscillations. And typically here we talk about the magnitude of the oscillation. So if we do that, then we probably have to put a 1 over 2 factor in there as well.
Right. So if you put the 2 factor in there, you could see that later you're going to come up with a number 4. Well, obviously you put 2 in the lower part of the fraction, you're going to make the number twice as you're going to be dividing 2 into. So you're going to divide your 4 into 2 into your 4 and end up with 2. So you're going to end up with the right answer instead of the wrong answer.
But if we simply understand that we're simply talking about the average or RMS values of the electric field oscillations, that's the proper equation. Another way to write that equation would be realizing that...
So he's arguing it's proper when it's it's wrongly premised. Because again, it's premised based on the fact that those two original sources were already go through one polarizing filter. So half the light has been broken, can't be seen, but it's still there, and you can reclimate it. And that's the point. So those are half beams and half beams. And yes, when you put the two broken halves together, you can recreate the strength of the original beam.
That C is equal to 1 over the square root of epsilon sub naught times mu sub naught. We can say that this can also be written as I is equal to, let's say, epsilon sub naught C times E squared. So either one would be the correct way of expressing the intensity of light. So if the intensity of the first beam is equal to I1 and the intensity of the second beam is equal to I2, when you put the two beams together, they're in phase. What would be the ultimate intensity? All right, if we, for example, use this as the intensity of light, we can say that I1 would then be equal to 1 over mu sub naught times C times E sub 1 squared. If we now take the intensity of the second beam, I sub 2, which is equal to 1 over mu sub naught times C times E sub 2 squared, what would now be the intensity of the two beams put together? And the first impression would be, oh, that's simply the sum, but that's not really the case because they're proportional to E squared. So that means that E total of the two beams together, if they are in phase, of course, if they're out of phase, the intensity is 0, but if they're in phase, it'll be the I over mu.
So again, the point would be is if you could perfectly reconstruct all the bits broken by the first filter, you would end up with this result. But there is no mechanism for doing that, because you really did lose some of the value of the photon. Some part of the photon wasn't just broken in some way where it just pulled your leg off and it just put your leg back on. No, it was actually degraded, and so you'll never get back all of what you had, because you did lose some measure of the energy when you went through the slits. You did break, you knocked fragments, pieces off of the photon, and you can't put the pieces back together, all of them. You can just take the fender that fell off of one car and put it with the fender that fell off the other car and, you know, re-fender a car, but you'll never get back all the car parts.
Mu sub naught C times E total squared. And of course we can say that
So I'm just arguing this is just an ideal circumstance. It doesn't happen in the real world anywhere. No polarizing filters. You can't do that. You can't take the the two filters and then put a third, fourth, fifth, eighth, put in 10 more filters and get 100% of the light. Never get 100% back. You can never reconstruct all the photons because some of the bits are too broken. There's too many pieces missing. You're rebuilding from the parts. So you take a car and you bash some pieces off of it. You left those pieces behind, and what you're just hoping to do is the pieces still going forward. Okay, you can still make some cars out of it, but you're not going to get back all the cars. You're going to have some leftover bits.
1 and E2 would be the same in magnitude, and if we can then say that that is equal to E sub naught, so we can say that E total could be said to be E sub naught plus E sub naught. And E sub naught in this case simply meaning the magnitude of E1 or the magnitude of E2 because they'll be the same. Then we can say that E total, the magnitude of E total, is simply equal to twice the magnitude of E sub naught. And if we then plug that in here, we can say, well, this is equal to 1 over mu sub naught times C times twice E sub naught quantity squared.
So he had this simple equation where he just had the E equals 2 E's. Why didn't you just stick with the simple one? Instead, he takes the simple one and puts it into the complex one and breaks all the E's again.
Which means that this is equal to 4 times 1 over mu sub naught C times E sub naught squared. And of course, 1 over mu sub naught C E sub naught squared is simply the intensity of either beam 1 or beam 2. And of course, if I want to call that, if I can say that I1 is equal to I2, which is equal to I sub naught, then I can take this here and replace that by I sub naught. So the intensity of the two beams that come together in phase is equal to 4 times the intensity of either beam by itself, which is really interesting.
No, he calls that really interesting. No, it's really preposterous. It's obvious that doesn't happen, or we take advantage of it all over the place because we can make 4 times the energy by putting, energy 1 in and energy 2, 1 values, and then all of a sudden we get 4 out. 1 plus 1 equals 4. Yeah, that's free energy then. I mean, it obviously doesn't happen. The whole thing is just nonsensical. So again, but I can make it sensible to you by explaining. No, those first 2 beams essentially went through a polarizing filter. Half the photons aren't seeable. They're not in a seeable condition. They're not mint anymore. They're a little bit messed up. And then when I take those messed up ones and I smash them into the same location, I can get back 30% of the photons.
So if I know that the intensity of this beam is I sub naught, and the intensity of this beam is I sub naught, and the 2 beams come together, the intensity of both beams, I total, if they're perfectly in phase.
There, if they're perfectly in phase, something he didn't say from the beginning, which is impossible to create with light sources, but it is possible to create with radar. And so again, we're back to the radar experiment, and the radar experiment only demonstrates this result It normally does this 4 times. You know, when the two line up, they're 4 times the signal. The tone is 4 times louder. Well, the tone is 4 times louder because you put it through an amplifier. You turned it into a sine wave. And the implications of doubling a sine wave is that you quadruple the volume of the wave. I mean, this isn't nuclear science, and this is just so wrong the way they're saying this.
Is actually equal to 4 times isotop. And that's a very interesting result.
It's a preposterous result. We know it doesn't happen. So why are you saying it? Because it can't happen that way. 2 regular beams can't, even if they're in phase, create 4 times the intensity. They can't do that. So you have to explain where the extra intensity comes from. If you're going to say there's 4 times the intensity at the location, then you have to concede that the 2 beams contain the elements, okay, of a potential for 4 times. And again, no experiment demonstrates the 4 times. So this is a perfect circumstance where you have complete reconstruction of every single photon, and you can't reconstruct every photon. So there's no experimental results that indicate this happens or this is true.
Of the interference of light when the 2 beams come together and they're perfectly in phase. For example, if the extra distance is either lambda or 2 lambda, 3 lambda, or so forth, or of course, if the extra distance is 0, you also have the same result. And that's how you look at the path length difference and how it affects the intensity of light when it comes together by having either constructive or destructive interference.
Yeah, and just complete nonsense based on a silly end product, not proven by any experiment. You don't get any 4 times the energy out of 2 regular beams. Of course, they already have to be in some way. They have to be. They have to be in their wave function form. To use their rhetoric. They have to already have the components of all these extra photons that you're going to make. So anyway, I mean, just clearly wrong. Clearly a poor way of explaining the phenomenon, and again, based on a notion that's never been proven, that photons are some kind of wave. They're particles first. You want to say the particles are waving? Fine, but it's quanta. Particles, discrete bits, moving at discrete speeds in discrete order, creating a frequency. That's what photons are. They can look like a wave, just like soldiers can look like a wave, okay, a whole bunch of them, but individually they're doing an individual thing that has nothing to do with any group behavior. They don't care about the group. They're not functioning as a group. They're functioning as individual soldiers doing one thing, heading for a location. All right. I mean, like I said many times before, all I can do is reason with you, and I can't make you reasonable. And it's just the sad truth. So, till the next time and such. I mean, maybe we'll play a few more of these to see how things go. But, you know, it's all just a terrible foundation for the real phenomenon.